So, I am Jason Daly. I am a software engineer with Google Fiber, and I'm going to talk to you today about a few points of interest. We're going to talk about how we created a TV and DVR user interface with HTML5, CSS3, and Dart. This is running on embedded hardware, which might be interesting to some people, MIPS and ARM devices specifically. And we're also going to talk about how I use some Dart VM-based services running on these boxes, interacting with native code to handle some of the stuff that the browser can't do, dealing with sockets and native Dart extensions. So some of you might be interested in that as well. So about Google Fiber, a lot of you probably already know, but I'll cover it anyway. Google Fiber is Google's fiber to the home internet service. We offer customers up to 1 gigabit per second symmetric bandwidth, so upstream and downstream, 1 gigabit. We also have a TV package available with it, about 500 channels or so. High definition, fat bit streams. It really looks good. We're really proud of it. Currently, fiber is deployed in Kansas City, Provo, Utah, and Austin, with additional cities coming soon. I do not know when your city or neighborhood will get Google Fiber. I'm sorry, I cannot answer that. Those are very complex questions, way above my pay grade. I'm just a software engineer, so I can't answer that question. I'm sorry. At Fiber, we use several pieces of custom hardware for the TV service. So the storage box, which has a 2 terabyte hard drive in it. In recent versions of the software, it combines with the network box. We call it the Network Plus box. There's one of these per household, so all your video goes onto one box, and then you can have several TV boxes. So 1 TV box per TV, up to 6 per household. That's a recent expansion from 4. A lot of people in Kansas City are happy about that because they have big houses there. And we've also got the network box in the original hardware and the fiber jack, which none of those have Dart code, so that's probably the last time we'll hear about those. Sorry for the bad programmer art. Here's the best I could do with a picture. The pretty orange fiber cable comes in from outside of your house into the fiber jack. From there, it's Ethernet to the network box. Ethernet usually to the storage box, and either Ethernet or we can run over coax lines using the MoCA protocol, which makes it a lot easier to install in houses that don't have Ethernet built in. And then from the TV box, you got a nice HDMI cable or whatever to your TV. We had a previous UI and DVR system. It works well. It's serving thousands of customers as we speak, but it's got several things that are not done right is a very objective thing, but it's not done the way that Google usually does things. For example, lots of heavy work is done redundantly on these little limited embedded devices. The electronic program guide specifically is a huge piece of data when you consider the size of the device we're talking about. That's hundreds of channels times 2 weeks of time. There's lots of data other than just the name of the show and what time it's on in there. There's lots of metadata that goes with it. And we distribute that to each and every storage box in the fleet. And that's probably not the best way to do it. Also, there are some very complex tasks that get done on the storage box. DVR scheduling, which is where when the user sets up a recording rule, say I want to record Law & Order, show me every single episode of Law & Order that you can find. A lot of computation has to be done. Well, when's Law & Order on? Have I already recorded this episode of Law & Order? Do I have enough tuners to record this episode of Law & Order with everything else I'm recording? And that's a very complex problem, and we do it on a little MIPS processor, ARM processor. Also, search, when you want to search for a program. That's a complex task, dealing with, I've typed in 3 letters, what matches that kind of thing. So, and that's all being done, again, on the storage box. Mostly this is implemented in Java, which means we require a third-party JVM license to run on each device. And the JVM we're using is not a Google JVM. It's not something we control. So whenever it breaks, and it does, we have to deal with external vendors to help us fix it. On the other hand, the previous UI and DVR system does have some native code that's been tuned specifically for our hardware for performance-critical tasks, and a lot of that we can reuse, so that's good. For our new solution, we wanted to do several things. We wanted to move most of this heavy lifting to the cloud, so the big data and the big computation moves into the cloud. Also, we wanted to move some of the users' data to the cloud, specifically their preferences and their settings, and the DVR recording rules, so that when one of their boxes goes down and we have to replace it, they don't have to go set up everything again. At this point, recorded video is staying on the hard drive, mainly because of licensing reasons. We can't move that to the cloud. This has advantages, obviously. The large data sets, such as the program guide, can be queried instead of copied all the way down to every single device in the fleet. Whenever somebody hits guide on the remote, it just asks the data center, and the relevant piece of data comes down for, say, 7 channels in 90 minutes, as opposed to 500 channels in 2 weeks. Also, the complex tasks, such as scheduling and search, can be done by a data center, as opposed to a TV box with limited capabilities. And again, user data is not lost if a box breaks. The settings and the recording rules are safe. The recorded video is lost, but as soon as you get the new box, it'll start recording all your stuff again. We still need a UI that runs on the TV box, though, so we can't do everything in the cloud. For our goals for this were, we wanted it to be at least as responsive as the existing UI. We didn't want to go backwards in terms of performance. We don't want to rely on third-party code as much as we can. We want to do as much as we can in-house because we can fix things in-house really easily. And we wanted this to be easy to develop, easy to maintain, and easy to deploy. So the decisions we made was an HTML, CSS-based UI running inside Chromium, and the front-end UI code written in Dart. Why did we pick Dart? Well, this is the laundry list you've heard over and over again this couple of days. Dart looks and feels like a lot of other languages that people already know. Most of us on the team, we're not front-end engineers from background. A lot of us came up from C++ or Java, and Dart looked a lot like the stuff we already knew. And we liked a lot of the features in Dart too, the strict type checking when you want it, and the libraries and imports. It's going to be a big project, so we wanted to be able to package up code modularly and reuse it, which, yes, you can do that in JavaScript, but Dart makes it a lot prettier and a lot nicer to deal with. Also, Dart still has the dynamic and asynchronous features that web apps need. So the dynamic types, you don't need types if you don't want them, and the futures and streams. We're not using async await yet. This happened 2 years ago, so we didn't have that available yet. We're looking forward to using it, but at the moment, if it's not broke, don't fix it. We're following that paradigm. Also, Dart is not limited to just the browser and web apps. I'll talk a little bit more about that later, but we like that going from the beginning. So, using HTML, CSS, and Dart, we had a lot of wins in development. Everybody's talked about how great the Dart tools are. Dart's really easy to pick up compared to JavaScript if you're already a programmer and you haven't worked with JavaScript already. We really like Dartium because the prototyping is just bam, it's done. You write the code and it runs. You make a change, it runs. You don't need to recompile, you just refresh. And even with CSS and HTML, you don't even need to refresh sometimes. You just change it in the debugger and bam, there it is. And the UX designers really like that. Can you make that red, make that a little bit bigger and move it down 5 pixels? Sure. Okay, good. That was really a nice experience. For deployment, as opposed to packaging up a big firmware image and sending it down to every box in the fleet, now we can just say, hey, go to this URL instead of that one. And now we've got a new UI deployed. That's really cool. That's really, really cool. And also the server-side software in the cloud can be updated. We don't need to deploy an image for that either. So when the back end needs to change, that just happens, and the customers don't even know the difference, except that stuff works better. We did have some challenges with this, though. Most of the packages and libraries and everything out there for doing web development assume you have a mouse and a pointing device. We have a remote control. We have up, down, left, right, and OK. So we didn't really find any widget or development libraries, frameworks, anything like that could really work for us. So we had to develop our own widgets, custom widgets, navigation system, and all that. It wasn't terribly difficult, but it was a challenge we had to overcome. Again, we have a limited CPU, limited GPU, and limited memory, so we have a lot of effort went into managing screens and DOM elements efficiently. We don't create divs and throw them away. We try to reuse them as much as we can, so there's less garbage collection and everything. Also, for the big data sets like our video-on-demand library, we don't request everything at once. We get pages at a time. We worked with the back-end team to give us small chunks of data that we can handle easily. Also, there's the challenge of interfacing with the hardware. This is it's an embedded CPU. It can't do software video decoding. There's dedicated hardware for that, and so also dealing with digital rights management, which we have to do. It's no content provider will talk to us if we didn't have some kind of way of protecting their content. So we had to deal with that. Largely, this was accomplished outside of Dart with native code. So we have a custom build of Chromium with a custom video tag that we can move around the screen. That talks straight to the decoders. And some of the existing native software that was working with the old system, we refactored parts of that and moved some of it into Chromium. Some of it stayed on the storage box. And so that's how we dealt with getting the video actually decoded so you could actually watch TV. Here's some screenshots. This is our program guide. This particular screen is mostly using Canvas right now. We're looking into a WebGL version of it to make it animate a little bit quicker, but other than that, it works pretty well. This is the on-demand library I was talking about. So here's one page with 10 different shows on it. You can see some of them bleeding off to the side to let you know there's more content. If you just arrow over, it goes over there, fetches the next page, and moves on. Some detailed info. So this is an episode of how it's made. All that data comes from the guide. And this is the DVR. So this is what's going to be recorded coming up. Now, that's great for the UI, which it worked really well. We were moving forward. We were really happy. We liked Dart. But the browser can't do everything, it turns out. We need to be able to record video to disk. We need to be able to play back video from the disk. We need to be able to delete stuff from the disk. We also have some third-party applications, like we have a Netflix client on our TV box. We need to launch that. None of that is something that the browser can do. So we had to do some of this we handled with native code. Again, recycling some of the code we had in the old system that was already tuned to run really well on our hardware. So the recording and the streaming is how we dealt with that. And the other tasks that weren't so performance critical but were still very necessary, we decided to write some services running in the Dart VM to do that. Again, why Dart? Well, it makes sense. We already have a bunch of Dart code. Let's write some more Dart code instead of having to switch languages back and forth all the time. Dart works just great outside of the browser. There's no limitations on that at all, or very little at least. And we also could do a lot of code reuse this way. So things like the interfacing to the code that interfaces with the back end, we could use that on both inside the browser and outside the browser in the VMs. Some of the logging we do so when something breaks, we get a flag immediately. That needs to be done consistently, so we recycle the loggers and other things like that. It made sense to be able to reuse all this code, so we decided to pick Dart again. The DVR service, this one runs in the Dart VM on the storage box. This service handles live TV tuning. It handles recording, playback, and file management. The recording instructions, which come from the cloud, are executed by this service. Basically, when you set up recording rules in the TV client, that sets up recording rules in the cloud. The cloud does a bunch of processing on that and turns those into specific instructions, which say record channel X from time Y to time Z. Those come down to this service on the storage box, and the storage box handles those instructions, recording that video. Also, when the disk fills up, we need to be able to delete files to free up space. So files are deleted, again, according to instructions from the back end, because that's a complex task, figuring out what file should I delete before what other files. Also, this service interacts with native code to control the actual capture and streaming. So we have, on our storage box, we have 8 tuners, which are not really tuners. They're basically just threads that write to the disk. So we can record up to 8 things at once, and also we can stream 6 things at once because we have 6 TV boxes. So you can be recording 8 things and streaming 6 of them to your TV, or 6 other things if you have stuff recorded. That's something that really screams native code. That's not something we want to run in a VM. We want to run that as close to the metal as possible. So we recycled a service that was used in the original software. We basically didn't even change it. We just copied it onto the disk and started talking to it, just like the old code did. Most of that is done with TCP sockets. Also, this service writes out some metadata files while it's recording, And we needed to be able to read those to do things like determine how long a file is, not in bytes, but in seconds. How many seconds is this file of video? And to do that, we wrote a native extension that talked to one of that service's libraries. So we just write a real simple Dart wrapper around that. We can call methods into that library, and we can figure out things like how long is it, or how far in is 50 seconds, so we can seek to a certain point in the file. We also interact with the TV itself, the TV UI, that part that's running in Dart. We use a WebSocket for that, so when the user wants to change a channel, hits channel up on the remote, that sends a command to the DVR service that says, stop recording what you're doing, start recording this new channel, and then start streaming it to me. And then additional native extension we had to write for to interact with the operating system, mainly because Dart doesn't have a version of StatVFS, if you're familiar with that, to look at how big file systems are, or, how big they are, how much is used, and how much is free. And that's something we needed to know to be able to know when the disk is filling up and to ask when what files we should delete. So that was a real simple wrapper that took like a day to write. It was not even a day, really, like an hour. It was really, really super simple. Also, we've got a TV box service. This is outside the browser again, and this is handling things, again, that the browser can't do. Specifically, we need to be able to switch applications. We need to be able to start Google Fiber TV when we want. We need to be able to shut it down, switch to a third-party app, say Netflix or YouTube, and we also need to be able to turn it off. And once we turn it off, we need to be able to turn it back on again. So we needed some additional smarts outside of the browser to be able to do all that. We also we have a mobile client, and the mobile client, in order to control the TV, needs to be able to talk to a service that can interface with the browser. So again, we have another WebSocket open for that inside of this service to let mobile clients connect and be able to control TVs. We also do things like, we say you switch from 16:9 to 4:3. That's not something we can do inside the browser because that's dealing with video hardware itself and not just the video. So we need to be able to switch video streams, switch audio streams. Also, closed caption data comes down. That doesn't come through the video tag that we have. Instead, it's routed outside through another socket. And also DRM, fetching DRM keys from our secure service to be able to install the keys on the device and be able to decrypt video properly. That was done by this service. So this new TV UI and DVR system we launched in mid-January this year to new customers. We don't have a migration path just yet, but it's coming up really soon. And so far, customers are pretty happy with it. It's pretty seamless going from one system to the other. It's hard to tell the difference unless you're really familiar with it. And we're happy about that. In conclusion, we really like Dart. It made developing this stuff was fun because of Dart and all the tools we have. We really enjoyed it. Dart is versatile, it's powerful, it's fun to develop with. It also works just fine on embedded hardware. We might have had 2 or 3 really minor issues that were handled really quickly by the VM team during this process. So we couldn't be happier with how well it works on our boxes. And with that, are there any questions?
I'll be question monkey. Would you like a mic? You like how I just materialize on stage in time for this?
Hello. Going forward, are you going to focus on either ARM or MIPS, or are you using both on purpose?
We do have new revisions of the customer equipment coming up. I can't really talk about which way we're going.
Okay.
A lot
Thanks.
of it is undetermined at this point, and I think even if it was determined, that's not something we talk about publicly.
Anyone else?
Back here.
How did you deal with managing shared objects and shipping them in packages for the shared wrapper objects, the native wrappers?
Oh, for the native extensions?
Yeah.
It's part of the. I might have been a little bit misleading. The browser and the back-end code, we don't have to ship new firmware images for. For the VM services that run on the boxes, those are part of the firmware. So it just packs up right along with the firmware.
Any more? Probably do one more question. Or not? Or okay?
Thank you so much.
Thanks a lot.